we try to factor a quadratic expression, we first want to analyze what the structure of the quadratic is. And in standard form, a quadratic usually looks like this: ax squared plus bx plus c. We're going to look specifically at the case where a is equal to 1. So we have just a 1x squared. When we're factoring these, you saw a lot of this with multiplying the two binomials, and now we're going to undistribute and put them into a product of two factors. The first part of the factors is coming from this x squared. So if I tried to figure out what things multiplied to give me x squared, that would just be x times x. We're going to skip over the middle term and go straight to the constant term, because the constant term is just the product of the last part of the factors. So something times something gives me 20. Let's find out what could those factors be. That could be 20 and 1. It could be 10 and 2. It could be 5 and 4. So any combination of those might work. If I tried 20 and 1 and I multiplied it back out, I know that x times x is giving me the x squared. I'm not looking for that right now, but we are looking for that middle term. So if I distributed from the inside and outside, I would get a 20x and a 1x. There's no combination of 20x and 1x that's going to combine to give me a negative 9x. So I know that that's not going to be a correct factor. This is why the guess and check method takes a little bit of time, but as you really get good at factoring, you won't have to check every single one. You'll realize that maybe 5 times 4 is a better option. So 5 times 4 does give me 20, and if I combined 5x and 4x, I could get a 9x. I do need a negative 9, which means I would need a negative 5 and a negative 4. But let's just double check our signs as we multiply. So x times x would be x squared. X times negative 4 was the negative 4x. Negative 5 times x is negative 5x. Yes, that gave me the negative 9x we wanted. And then even if I distribute negative 5 times negative 4, I do get the positive 20 that we needed. So the correct factoring for this is the x minus 5 times x minus 4. The second one, we have m squared minus 2m minus 8. We're going to undistribute and start with that quadratic term. So what things multiplied to give me an m squared would just be an m times m. Things that multiplied to give me 8 could be 8 and 1 or 4 and 2. So let's try 4 and 2. And then we check our factoring. So I'm going to redistribute. I get 4m and 2m. Somehow that needs to combine to give me a negative 2. So if I just add those together like that, I get a positive 6, but that's not going to help me. I need a negative 2, which means I would need a negative 4 and a positive 2m to give me a negative 2m. So let's put that negative 4 and a positive 2 there and double check. M times m is m squared. We know that the 2m and negative 4m give me the negative 2m we want. And negative 4 times positive 2 is a negative 8. So the biggest thing is to double check your signs, but this did factor into m minus 4 times m plus 2. And oftentimes you'll be checking yours, or you might be doing it with a friend and they do it slightly different. So m plus 2 times m minus 4 is the exact same thing, because the multiplication property is commutative. I can multiply two things, so if I said 3 times 5, that's the same thing as 5 times 3. So I can swap the order of that multiplication. So these two things are equivalent. In number 3, let's try to do that one. I have k squared, which would have come from k times k. Then we have factors of 48. So What things could multiply to give me 48? Well, there's a lot. You could have 2 and 24. You could have 1 and 48. You could have 3 and 16, or 4 times 12, or 6 times 8. There are so many ones that you can check, but as you get better at it, you'll start to figure out that maybe you don't need to check every single one, and you'll find the factors a little bit quicker. So if I had checked, let's start with 6 times 8. This guess and check method builds over time, but k times k was k squared. We know that. Let's check the inside and the outside to see what that combination is. So 6k and 8k would combine to give me a 14k, which is what we want. We need a positive 14k, and a positive 6 plus 8 does give me 14. We double check the last part as well. So 6 times 8, positive times a positive is positive 48. So that's how it would factor into k plus 6 times k plus 8. And number 4, we have an m squared plus 10m plus 9. So m squared came from m times m. Factors of 9, there's only a few options. So you could do 3 times 3 or 9 times 1. If we did 3 times 3, we're going to realize that we have 3m and another 3m, but those don't combine to give me a 10. So that's not actually going to help me. If I change the factor from 3 times 3 to 9 times 1, that still multiplies to give me 9, but it gives me a 9m and a 1m, which does combine to give me 10m. So that's what we wanted, a positive 9 and a positive 1 to give me a 10m. It did multiply to give me a positive 9. So our factored form would be m plus 9 times an m plus 1. Alright, so I would pause the video and try some of these on your own. See if you understand a little bit of what's going on. And when you're ready, you can press play and check your work. Okay, so if you have already done this on your own, you factored and you found something like x minus 9 times x plus 7. For number 6, you saw r minus 6 times r plus 1, or you could have had them in a different order, r plus 1 times r minus 6. But the sign does need to be negative with that 6. 7 was a little bit different because you saw p minus 3 times p minus 3. So it's the same thing twice, and that's okay. It means that you could have also rewritten that as p minus 3 squared. So either one of those would have been appropriate as far as a factored form. 8 should have been m plus 7 times m plus 6. Now I'm going to give you two more, and these can be classified as a special case. These are called difference of squares. You'll see these pretty often, but with the difference of squares, what you'll notice is that there's no linear term. You know, where we have ax squared plus bx plus c, this time this middle term is 0. So in that case, we need a 0x in the middle. So x squared came from x times x. 25 would have been the product of 5 times 5. For me to get a 0x, I would need a positive 5 and a negative 5. If you check your work inside, you get a positive 5x. Check your work outside is a negative 5x. 5 minus 5 is 0x, which is why we didn't have that linear term. It does get a negative 25 because you had a positive times a negative. So this would be our factor form, x plus 5 times x minus 5. And then a squared minus 9. This comes from a times a to give me a squared. 9 is 3 times 3. But again, I need a 0x, so I need a positive 3 and a negative 3. This is called the difference of two squares because each part of that quadratic is a square. So a squared and 9 is a perfect square. It's 3 squared. And we're doing difference. If that had been plus, it would not have factored. So try some of these out on your own. Do some of the practice that is posted, and that should help you out a little bit more. Then you can feel comfortable enough to move to the next level of factoring.